Hello, my name is Yamkama Ronald, and I'm going to be going through week 6 backup and monitoring configuration. And because my Microsoft student account, the credits expired, so I'm just going to make a simple presentation to take us through the steps. Take through the step that we would use to make the backup and monitoring. So first of all, we have, so in this phase of the system build, the objective is to design and implement a backup and monitoring solution for 6 virtual machines, and the purpose of this step is to ensure that the infrastructure is reliable, protected against data loss, and continuously monitored for performance and availability. So this stage focuses on operational stability rather than deployment. Yeah. So going on to the next slide. So the objective of this phase. So the primary goal of this phase is business continuity and system health. So a properly designed environment must be resilient against failures, outages, and unexpected data loss. So to accomplish this, both automated backups and performance monitoring must be implemented. These two components work together to protect the system and maintain reliability. Yeah. So as you can see, this is accomplished using the backup policies and the monitoring tools. So going to environmental overview, the infrastructure consists of 6 virtual machines distributed across 3 departments: 2 for sales and marketing, 2 for engineering, and then 2 for customer success. Each server performs important operational roles, so every system must be equally protected and monitored. This ensures consistency in security and reliability across the entire environment. So each server must be protected and monitored consistently. So going to the backup and strategy planning, you can see that before configuring backups, a strategy must be designed. Planning is essential because backups affect performance, storage usage, and recovery capability. So key factors include how often backups should run, and how long they should be stored, and how securely they are protected, and how quickly systems can be restored. The overall objective is to minimize downtime and data loss if an incident occurs. Yeah, so slide 5 is creating a recovery board, and the first technical step is creating a recovery services board. So this board acts as a centralized location where backup data is stored securely, separating backups from production resources, and ensures that even if a server becomes compromised or corrupted, the backup data remains safe and accessible. So this design follows the best practices for disaster recovery architecture. Then we are going to see how we configure backup process policies. So the backup policies determine when backups run and how long recovery points are retained. For example, daily backups may be configured for active systems so recent restore points are always available. Weekly and monthly retention settings can also be configured for long-term recovery and auditing. So proper policy configuration balances storage efficiency with the recovery flexibility. Then we can see assigning backup to virtual machines. After the policies are created, each virtual machine must be assigned to a recovery port and linked to a policy. So once assigned, the backups run automatically according to the defined schedule. This automation eliminates the need for manual intervention and ensures protection is always active. So automated backups reduce man error and improve reliability. Then we're going to see the purpose of the backups. So the purpose of the backup is to protect systems against multiple risks. These include accidental file deletion, operating system corruption, malware or ransom attacks, and even hardware or platform failures. If any of these events occur, the administrators can restore the system to a previously functioning state quickly, reducing downtime and operation impact. So we can see the monitoring strategy, and in addition to backups, monitoring must be implemented to observe system health in real time. So the monitoring tracks performance metrics such as the CPU usage, memory consumption, the disk activity, and network traffic. These metrics provide visibility into how the systems behave under load and they help administrators detect performance problems before they affect the users. Then configuring the monitoring tools. So monitoring is configured through platform monitoring services that automatically collect performance data from each virtual machine. Once connected, the system continuously gathers telemetry and performance statistics. This ensures administrators always have up-to-date visibility into system status without needing to manually check each server. Then after that, setting alerts. So alerts are created to notify the administrators whenever abnormal conditions occur. For example, alerts can trigger when CPU usage exceeds a safe threshold, a disk space runs low, or the server becomes unavailable. These notifications allow administrators to respond immediately, preventing small issues from becoming major outages. Then we can see the logs diagnostics. So in addition to performance metrics, system logs record activity and events. Logs are valuable for troubleshooting problems, auditing administrative actions, analyzing performance patterns, and meeting compliance requirements. They provide historical records of system behavior that helps identify the root causes of issues. So now we're going to see why monitoring matters. So monitoring is essential because it provides visibility into system behavior. Without monitoring, administrators would only discover problems after systems fail. And with monitoring in place, issues can be detected early, corrected quickly, and prevented from affecting users. This proactive approach improves reliability and reduces downtime. Validation of configuration. After configuration, the system must be validated. This includes checking backup status to confirm protection is active, verifying the time of the last backup, reviewing monitoring dashboards for live metrics, and confirming alert rules are configured. So the validation ensures the system is working exactly as intended. And then these are some of the business value that are backup and monitoring. So this solution provides significant business value. It protects company data, improves system availability, and increases operational awareness and shortens incident response time. These benefits are essential for production environments where reliability and uptime directly affect business success. So we can see that this phase focuses on building a reliable infrastructure foundation. Backups provide recovery protection in case of failure, while monitoring provides real-time insight into system performance and health. Together, these systems create a secure, resilient, and production-ready cloud environment. So thank you for watching this video.